Hello everyone, I am Dr. Hirok Borah, Assistant Professor of Assam Downtown University. In this video, I am going to describe one chemistry practical. The practical is estimation of iron present in Mohor salt using potassium permanganate. Now I am giving you a brief description about oxidation reduction titration involving potassium permanganate. Potassium permanganate is a very powerful oxidizing agent in acid medium. This is the reaction of potassium permanganate in acid medium. Since the medium is acid, and sulfuric acid does not react with potassium permanganate in dilute solution, therefore sulfuric acid is the most suitable acid to be used. And potassium permanganate solution are purple color and very dilute solution is pink color. Therefore, on reduction, colorless manganese ions are formed. Therefore, in titration of potassium permanganate, no indicator is necessary. That means potassium permanganate acts as a self-indicator. Now, potassium permanganate cannot be used as a primary standard. So therefore, we have to standardize the potassium permanganate using several reagents. One of the reagents is oxalic acid. Now I am going to explain the theory of this experiment. When potassium permanganate and Mohor salt are react, this is an oxidation reduction reaction or redox reaction in which potassium permanganate solution is oxidized and Mohor salt solution is reduced. So in this reaction, iron 2 is oxidized to iron 3 by potassium permanganate in acid medium. So this is the reaction between potassium permanganate and iron. This oxidation reduction reaction. Now I am going to the requirements of this experiment and its preparation. The first requirement is 0.1 normal potassium permanganate solution. We prepare 0.1 normal potassium permanganate solution by taking approximately 1.6 gram of potassium permanganate dissolved in 500 ml water. One another requirement of this experiment is 0.1 normal oxalic acid. We prepare the 0.1 normal oxalic acid by taking approximately 1.6 gram of oxalic acid in 250 ml water. One another requirement of this experiment is ferrous solution, that is Mohor salt solution. We prepare the Mohor salt solution by taking 5 gram of Mohor salt and dissolve in approximately 200 ml of water. One another requirement of this experiment is 4 normal sulfuric acid. We prepare 4 normal sulfuric acid dissolving approximately 10 ml of sulfuric acid in 90 ml of water. One another requirement is phosphoric acid. Now I go into the procedure of the practical. The first procedure is standardization of potassium permanganate solution against standard oxalic acid solution. It is also one oxidation reduction reaction. The reaction between potassium permanganate and oxalic acid is this. The next procedure is estimation of iron 2 in Mohor salt. Now let's go to the procedure of this practical. For estimation of iron present in Mohor salt, we use 0.1 normal potassium permanganate solution. Since potassium permanganate is a secondary standard, first we have to standardize the potassium permanganate solution using 0.1 normal oxalic acid and 4 normal concentrated sulfuric acid. Now we are going to standardize the potassium permanganate solution by standard 0.1 normal oxalic acid solution. First we take 10 ml of oxalic acid in a conical flask. After that we take 10 ml of 4 normal sulfuric acid. Now we heat the reaction mixer approximately 60 minutes. We take potassium permanganate solution in burette. Now we are going to titrate oxalic acid using potassium permanganate. Since potassium permanganate is self-indicator, therefore at the end point the color of the oxalic acid solution in conical flask becomes pink. So this is the end point of the titration. So from the burette reading we calculate the concentration of potassium permanganate solution. So in this way we standardized potassium permanganate by oxalic acid. Now we prepare the Mohor salt by adding 5 gram of Mohor salt, approximately 250 ml water and 10 ml of 4 normal sulfuric acid. We also add approximately 5 ml phosphoric acid in the solution. Now we take approximately 20 ml of Mohor salt in a conical flask. Now we are going to titrate this Mohor salt using potassium permanganate solution. Now we titrated Mohor salt by potassium permanganate solution. At end point the color of the solution becomes pink. This is the end point of the titration. So in this way we determine the amount of iron present in Mohor salt. Now we are going to explain the calculation of this experiment. First we calculate the strength of potassium permanganate. We take 0.1 normal oxalic acid and the volume of oxalic acid is 10 ml. Now we have to calculate the strength of potassium permanganate solution. Now let's from the burette reading we found that at the end point the volume of the potassium permanganate is 10 ml. So using this formula we can calculate the strength of potassium permanganate. So if we put this value then we get the strength of potassium permanganate is also 0.1. So in this way we can calculate the strength of potassium permanganate. In this next part we calculate the amount of iron present in Mohor salt. Now we found that the normality of potassium permanganate solution is 0.1. Now in the estimation of iron from end point, let's the volume of potassium permanganate is 10 ml. So using this equation, that means 1000 ml of potassium permanganate contains 0.005585 gram of iron 2 plus. Now since we get the value of potassium permanganate is 10, therefore when we calculated in 10 ml of potassium permanganate we get 0.00005585 gram of iron. Therefore in 250 ml solution we get 0.001392 gram of iron. Therefore in 1000 ml Mohor salt contains 0.005585 gram iron. So at last we get the result. That means in Mohor salt the strength of iron is 0.005585 gram per liter. In this way we can calculate the amount of iron present in Mohor salt. Thank you.